Very good evening, Chaitanya. How are you?
Yes, sir.
How are you? Then you know forum all everything.
Yes, sir.
Yeah. So shall I start the session?
Yes, sir.
Yeah. The session is actually we are discussing the what electricity chapter. Am I right?
Yes, sir.
In the electricity, I completed some part. Now I need to start the connection of the cells, grouping of the cells. Am I right?
Yes, sir.
So grouping of the cells. I'll start once again. Grouping of the cells. In the grouping of the cells, the first grouping is series connection. Series connection. Series connection of cell. Next one is parallel connection. Parallel connection of cells. And next one is parallel connection, series connection, and the next one is, tell me, mixed grouping, mixed connection or mixed grouping. First, let us start the series connection of the cells. Series connection of the cells. Series connection of cells. Series connection of the cells. So how the series connection of the cell? You know, cell is, this is a symbol for the cell. In the last class I explained what is the symbol here. This is series connection of the cells. I will take 3 cells here. I will take 3 cells. In the 3 cells, look at here, this is a positive terminal, this is a negative terminal, positive terminal, negative terminal, positive terminal, negative terminal. This is the way the cells are present. But how the connection takes place to say it is a series? Series connection means the negative terminal of the first battery is connected to positive terminal of the second battery. Next, same way, second battery negative terminal is connected to third battery positive terminal. This is the way. So and so on. Even a number of batteries are present. This is the way the connection will take place. Okay. Now this way they are connected. This cells grouping combinedly called as a battery. So now the series connection of cells is known as battery. Now this battery, this acts like a battery. Even though, what is the use of this connection? The use of the connection is it will give more EMF. So here the thing is EMF. What is mean by EMF? Generally here every cell provides EMF. Here if you join all the cells, you will get more EMF than a single cell EMF. But here, what is this EMF called? The EMF called is electromotive force. Electromotive force. What is this electromotive force? Electromotive force is the work done on a charge to bring from one position to another position is known as a electromotive force. Here in the name we have a force, but it is not a force, it is a work done to move a charge from one position to other position in the circuit. That is meant by the EMF. Understand? So that way every single cell has a EMF, which means that every single cell has a capability to perform or capability to move the object or capability to move the charge from one position to other position. That is known as a EMF. So every single cell has a EMF. When you grouping these cells in a series, you will get more EMF. Generally, EMF represented with the letter E. The formula for EMF is work done per unit charge. The formula for EMF is what? Work done per unit charge. So every cell has a EMF, means every cell has a capability to move a charge one position to other position. Understand? Now, here when you connect the series connection, the EMF value increases. But here, let us take the EMF first value is E1, second battery is E2, third battery is E3. Then what is the effective EMF or resultant EMF when you grouping in this series connection? When the effective EMF value is E is equal to, that is E1 plus E2 plus E3, which means that the effective EMF value is the sum of the individual EMF of the cells. Okay, when you are grouping the cells as a series, the effective EMF would be the sum of the individual EMF of the cell. So this is how to get a greater EMF. To get a greater EMF, we must connect the cells in parallel, so that you will get a greater EMF to work a appliances. So this is all about the series connection of the cells. Next, coming to the parallel connection of the cells. Let us take the parallel connection of the cells. Parallel connection of cells. So what is this parallel connection of the cells? Let's see now. So let us take three cells here once again. This is first cell, and this is second cell, and this is third cell. Here observe that this is a positive terminal, negative terminal, positive terminal, negative terminal, positive terminal, negative terminal of the batteries. Now the connection will be all positive terminals at one point, all negative terminals will be at other point. If you connected, the connection we can call it is a parallel connection of the cells. Understand? The connection, what is the meaning of this connection? What is the parallel connection here? All positive terminals of the batteries, all negative terminals of the batteries joined at single point is known as a parallel connection of the cells. Now here, what is the use of these cells? Actually, what is going to be the effective EMF? As individually they are having E1, E2, E3, likewise the individual EMF they are having, but what is the effective EMF of grouping of these cells? Just before, in a series connection, what happened? The effective EMF would be the sum of the individual EMF of the cells. But here, when it is in a parallel connection, the effective EMF would be, the effective EMF value is the greatest cell. The effective EMF value is the greatest cell EMF will be the effective EMF of the grouping of this parallel connection. So once again, here the example is what? The effective EMF of these cells is, what is the greatest EMF in among the all cells? Which one has a greatest EMF? The greatest EMF will be the EMF of the grouping of the cells. So that way, we will get the effective EMF for the grouping of the cells. So now I will give an example here. For example, the three batteries or three cells having 1 volt, 2 volt, another cell having 2 volt, another cell having 3 volt. Example I am giving here. They are connected in parallel. They are connected in parallel. Parallel means all the positive terminals at one point, all the negative terminals at other point. So the connection is said to be what? Parallel connection. But here the effective EMF of these parallel connection will be how much? Here this is 1 volt, this is 2 volt, this is 3 volt. Such a way I connected the cells in parallel. But what is the effective EMF here? The effective EMF in a parallel connection is the greatest potential or the greatest EMF value is the value for the parallel connection. What is the greatest potential here? Greatest EMF value here? The greatest EMF value is what? Here 3 volt. So this combination effective EMF will be the 3 volts. Okay, na? This is the way you will have the series parallel connection. Understand?
Yes, sir.
Yeah. Now next one is let me take some examples here. Series connection and parallel connection. Example number 1. What is the example? Here I am having 1 volt, 3 volt, 5 volt, 3 cells are present. Cells are present. Here how many cells are present? 3 cells are present. What is the voltage of these 3 cells? 1 volt, 2, 3 volt and 5 volt are present. The effective EMF of the cells, when they connected in series and parallel. When they connected in series and parallel. Tell me. Now first tell me, when they connected in series connection, what is the effective value? So what is the effective EMF in a series connection? Series connection. In a series connection, what is the effective EMF value? In a series connection, effective EMF value is E1 plus E2 plus E3. E1 plus E2 plus E3. When this is a E1 plus E2 plus E3, then E is equal to, E1 is 1 plus 3 plus 5, which is equal to 9 volt. So total the EMF of the cells is 9 volt. And next in a parallel connection. So in a parallel connection, what is the effective EMF value? In a parallel connection, the effective EMF value is the greatest value of the combination is the effective EMF of the connection. So here greatest value in this cells is 5 volt. So that 5 volt is the effective EMF. Understand? So this is the way the connection will takes place. Got my point? Got it?
Yes, sir.
Now let's go for another concept, heating effects of electric current. Next one is heating effects of electric current. So next concept is heating effects of electric current. Heating effects of electric current. When you are talking about heating effects of electric current, you are supposed to learn one concept, that is power, electric power. You are supposed to learn one concept, electric power. You are supposed to learn what is the concept, electric power. What is this electric power? Electric power is nothing but simply electric power generally anywhere we have in a physics we have in different subjects different powers will be takes place. Those are, if you take the concept of mechanics, you have mechanical power. If you take and what we can call optics, there you can see optical power. In the case of electricity, it can call as electrical power. So in different branch of physics you have different powers. So those all the things have different formulas and different concepts. But here in the electricity, the power is called the work done per unit time. Power is called work done per unit time, sometimes also called electrical consumption, electrical energy power unit. Electrical energy per time is also given as a electrical power. Understand what is the definition of the statement of the power? Sometimes we can call work done per unit time or electrical energy per unit time, both will give the same meaning. But what is the units for power? Generally the energy units are joule per second. So here energy units are joule and the time units are second. So simply joule per second is the units for power, and this joule per second also known as watt. This joule per second also known as watt. Understand? Now from here, if I write in a simpler manner, power is equal to energy consumed per time, and here energy is equal to, from this expression, energy is equal to, I can write power into time. So this is the formula for electrical energy in terms of the power. But here, based on this formula, we have units for the power, units for the electrical energy. That is, generally you know that power is equal to energy into time. Here energy is equal to power into time. Here power units are watt, time units are second. Watt second also a unit for energy. Okay, watt second also unit for energy. And not only watt per second, even another units also we have. Instead of watt, we supposed to take kilowatt. Instead of second, we can take hour. So kilowatt hour is also unit for energy. This kilowatt hour is using for calculating the electricity bill. The kilowatt hour is a unit for electricity bill. Generally we are having, generally in our daily life, we sometimes we used to call how many units of energy consumed, how many units of electricity has burned. That way our conversation takes place. But here what is mean by unit current? The unit current is nothing but 1 kilowatt hour. Understand? 1 kilowatt hour is equal to 1 unit of energy, electrical energy consumption. So finally, what is the conclusion here? 1 kilowatt hour is a practical unit of electrical consumption. Understand? Energy consumption. Joule is a SI unit of the energy, but here kilowatt hour is a practical unit of energy. So very important point it is. This is we are considering as 1 unit of electricity consumption. Now let us take the heating of the electric current here. Now let us go for the heating of the electric currents. In our daily life, many appliances are working based on the heating of the electricity. First one is bulb. So first one is bulb, normal bulb. Second one is heater or geyser. Third one is, can you tell me other appliances? Fuse. Other appliances are fuse. What is that? Bulb, heater, fuse. Any other appliances are working. Even iron box also. Heater or iron box. Iron box to make istri. Istri we use a heater or iron box, and fuse also working the same heating effect of the electric current. Tell me other appliances. The other appliances are electric cooker. So other appliances are what? Electric cooker. Electric cooker. So these are the appliances will work based on the heating effect. Here just now we have seen that how bulb is working here. Let's see here. So bulb here. Look at the bulb. Now in the bulb, imagine this is a bulb. In this bulb, this is a bulb. In this bulb, what we have? We have some filament. The bulb has a filament. Okay, filament. So this filament is made up of with generally tungsten. The filament is made up of with what material? Tungsten. Why do we prefer the tungsten as a filament here? Because here, so here this is a bulb is working on the what effects? Electric heating effect of electric current, which means that when you pass the electricity, it will produce the heat and also light. Understand? So based on that, it is working. But here, we do this work here. Here, the tungsten is act like a filament. This tungsten has a high resistance. The tungsten has a high resistance. Who is having high resistance? The tungsten has a high resistance. When tungsten has high resistance and even it has a high melting point, high resistance. Because of the high resistance, when you are sending the energy, what kind of energy we are sending? Electrical energy. Because of this high resistance, the total energy which we send it through the electricity is consumed by, is obstructing by this high resistance filament. Due to the obstruction, all the energy will drop across this filament. When all the energy dropped across the filament, that energy will come out as a heating, because here we can change the form of the here. Here what going to be happen? The energy is changing its form when it is dropped across the heating. What kind of energy to what kind of energy it is changing? It is changing from electrical energy to heat energy. So why the electrical energy is converting in heat energy? Because of the high resistance of the filament, the total energy dropped across the filament. Whatever the energy dropped across the filament, it is converting into heat energy. So that heat energy we are receiving to our surroundings. So that way the bulb is working based on the heating effects of electric current. And also one more appliances. Here what is the necessary things must be for bulb? The filament must be high resistance and high melting point. Why? What is the necessity having to the high melting point? When it gets heated, if it is not high melting point, it might be fuse, it might be get melt. That is the reason the filament must be have high melting point and also high resistance. This is all about the bulb. Now coming to the electric heater. So generally electric heater, if you see, it appears like this appears like, you might have seen this kind of heater. This is the way the heater is present normally. This is connected to wire. This is keep it in the socket. Okay, this is the connection. So now you will keep this is in water, so that way water get boiled. So now, but here what is the heating? Generally this heater will be made up of with nichrome material. Bulb is made up of with tungsten, and here heater is made up of with nichrome material. Why this nichrome? Nichrome material also having a stiffness material. It is a stiffness material, and it is having offers the high resistance. Because of the high resistance, as usually it will drop the energy. Whatever the energy dropped at here, it will provide that will converting into heat energy. That heat energy received by the water, so that water get heated. So that way the heating effects will be work for the heating effects will work for the currents. So this is also here also the conditions are what, that is made up of with what high resistive materials, but it must be have very stiff. That is the reason nichrome material they are using for making this what electric heater. And also even cookers also the same process. Even what cookers, what are the things I given just now? Heaters, cookers, electric cookers also working the same principle. But what about this fuse? Next appliance is what? Fuse. Very important it is in our daily life, fuse. Fuse also is working on a heating effects of electric current. Generally the symbol for the fuse, this is the symbol for the fuse. It is used for what? This is used for protecting the electric circuits. What is the use of this fuse? It will protect the electric circuits or electrical appliances, electric circuits. How this is protecting the electric circuit? It is based on the working. It is working on the heating effects of the electric current. How? Here generally the fuse is made up of with lead and tin material. Lead and tin material. It is a alloy. So it is a combination of lead and tin material. It is made up of with combination of lead and tin material. So this lead and tin material has a low melting point and high resistance. Low melting point and high resistance. That is the reason we are using the alloy. But what is how it is working? When more current flows through this appliance or flows through this fuse, it instantly get fused, it get melt. When it is get instantly, the circuit will break. So that is the reason the appliance will get safe inside. So here the concept of working of fuse is what? When more amount of the current is flowing more than the rated current. If the current is flowing more than the rated current, the fuse get melt. When the fuse get melt, circuit will break. So why the fuse get melt here? Because when you flow more current through the fuse, heat will be produced. That heat will be melt the fuse, so that circuit will break. That is how the fuse will work. But nowadays we are not using the fuse. Instead of fuse, we are using another kind of instrument, that is called MCBs. Another kind of things are, what is that? MCBs. What is this MCB? MCB means miniature circuit breaker. What is this MCB? Miniature circuit breaker. Here how it is works, the miniature, generally the miniature MCBs you can observe across the ACs, okay, beside across when it is plug in the ACs, or when you plug in the heavy loaded appliances using the MCBs, okay. Now how these are working? MCBs are working the same like a fuse. When it is get more current flows through the appliances, more current flowing through the appliances, the MCB button will be get tripped, okay. When the MCB button will get tripped, the circuit will be break, no current flows through the appliance. That is the way the MCBs are working. Here what is the difference between MCB and the fuse? Here when the fuse get melts, we have to remove and we need to keep the wire into that. But whereas when it is the MCB, there is no need of to remove the fuse and keeping the wire into the fuse. Those things we cannot do. Just we can, if it is strip the MCB, just we need to keep on the button one side. So that is the way the MCB is more easier to use than fuse. So that is the reason nowadays we are using this MCBs to break the circuit when the current flow through the appliances, okay. So this is what today's topic. In coming class we will discuss other topic, and also this week we will complete the portion, understand. So I will stop the
Okay,
session.
sir.
Bye.